Hello, today we are going to take a look at the determinants and inverses of matrices and also some of our equations using matrices. The first thing that we need to take a look at is the identity matrix. So an identity matrix is always going to be square, meaning it has the same number of rows as columns. So it's going to be 2 by 2, 3 by 3, 4 by 4, and so on. Your first row is going to start off with a 1, and then that is going to be the only one in that row and that column. The second row, second column will be a 1, and that's the only one in that row and that column, and so on. So the values where the row and the column are the same, so first row, first column, second row, second column, third row, third column, are going to have a 1. All of the other values are going to be 0. So for example, off to the right, we've got our 2 by 2 identity matrix and our 4 by 4 identity matrix, and we see that this diagonal line has all of these 1s here. Now, it is called the identity matrix because it's going to behave very similarly to other identities that we've worked with. So think about our multiplicative identity. Well, x times 1 is just x for any value. 1's our multiplicative identity. Additive identity, any number plus 0 is going to be equal to that number. So an identity matrix is going to be the same thing, but for matrices, for multiplication. So if we multiply any matrix by the appropriately sized identity matrix, then we are going to end up with that same matrix. So for example, let's take a look at this one I have down here. So we have this 2 by 2 matrix, so 2, 3, 4, 5, and we are going to multiply it by our identity matrix. So we multiply row by column. So 2 times 1 is 2 plus 3 times 0. Then for our first row, second column, we multiply our first row by our second column. 2 times 0 plus 3 times 1. And then second row, first column, 4 times 1 plus 5 times 0. Second row, second column, 4 times 0 plus 5 times 1. And this would be true if we multiplied our identity matrix first. So one of the ways that we can find an identity matrix is by taking the inverse of a matrix and multiplying that by the original matrix. So we are going to work by hand with 2 by 2 matrices just to see where these come from. The 3 by 3 and up are significantly more complicated, and we're not going to do those by hand. Take a look at video 8.0 to see how we would use our calculator for these. Now, the first thing that we need to do for finding the inverse of a 2 by 2 matrix is to find the determinant. So our determinant is, if we have our matrix set up like this, A, B, C, D, is AD minus BC is our determinant. So it's all of this in yellow. Let's take a look at what that looks like for these 2 by 2 matrices. So AD minus BC. All right, so it's a little bit like cross multiplication, what we've done with some other things. So our determinant is 1 times negative 2 minus negative 4 times negative 4. So our determinant is negative 18. If we take a look for number 2, so we've got negative 5 times 3 minus 2 times negative 4. So that will be negative 15 plus 8. So our determinant is just going to be negative 7. So determinants for 2 by 2 matrices, very straightforward, but a critical component of finding our inverse. Now, some of these will end up being 0, and that will be important for finding our inverses. But here are some other ones where, so you do 2 times negative 2 minus negative 6, so it will be a positive 2. All right, so our determinant, very straightforward to find. Now, for our inverse, we have to do this. All right, so we have to multiply our matrix here by 1 divided by your determinant, so our reciprocal. You switch the location of A and D, and you change the sign of B and C. All right, let's take a look at what that looks like. So the first thing here, let's look at 5 first. So the first thing we need to do here is find our determinant. And we can write this as 1 divided by, 0 minus 0. So for number 5 has no inverse because the determinant's 0. If the determinant is 0, you have to divide by 0 when finding the reciprocal, and that's a problem. So some of these don't have inverses. Others do. Like number 6 will have an inverse. So we do 1 divided by the determinant. So we've got negative 2 times negative 4 minus 2 times 0. And then, remember, you change the location of A and D. So you switch those. So we switch. So we've got negative 4, negative 2. And then you change the signs of these two. 0, we can't change the sign. It's not positive or negative. And then this 2, we change to negative 2. So how we're going to write this is going to be 1/8 times this. I highly recommend writing like this with the 1 divided by the determinant multiplied in the front, because that is going to make doing our calculations with this a little easier. So for example, let's just look at how multiplying these two matrices will give us our identity matrix. And we'll say like this matrix is A, so then this matrix is A inverse. So if you have A inverse times A, or A times A inverse, you are going to end up with the identity matrix. I know with other matrix multiplication, the order does not matter, but here, the order does matter because it's not commutative. When working with a matrix and its inverse, it is commutative. So let's go through and do that multiplication. So let's multiply A times A inverse. So we've got negative 2, 2, 0, negative 4. And the constant we can multiply at the front. It doesn't matter which side that goes on. And then we've got negative 4, negative 2, 0, negative 2. All right, so we multiply these. We've got row by column. And don't forget we have that 1/8 there. So negative 2 times negative 4 is a positive 8 minus 0, plus 0. Next, row by column. So we've got negative 2 times negative 2. So we've got 4 plus negative 4, so 0. Then our second row, first column. So we've got 0 times negative 4 plus 0 times negative 4. And then our second row, second column, we multiply row by column. So 0 times negative 2 plus negative 4 times negative 2. Then we multiply by 1/8. So when we're multiplying a constant by a matrix, we just multiply it to every term. So 1/8 times 0 is going to be 0. 1/8 times 8 is just 1. And oh look, that's our identity matrix. So it's going to be helpful for solving equations, which we're going to do in a minute. But first, let's just find our inverse of another one, just as some more practice. So we'll call this A, so our A inverse. So that's our reciprocal of our determinant. 1 divided by, we'll have negative 44 minus negative 40. And then switch the location of A and D. And switch the sign of B and C. So we simplify our constant here. So it will be 1 divided by negative 4, or negative 1/4. And there we go. So that is how you find the inverse of a 2 by 2 matrix. Now, we can use it to solve these equations that include matrices. So this x here and this z are names of matrices that we are trying to solve for. In order to do that, what we need to do is get rid of this. If it were, say, a constant and a variable, we could just divide both sides by this, but that's not how it works with matrices. So we need to find the inverse of this matrix A. Okay, like we'll call that A, we'll call that B. So our A inverse, so it's 1 divided by our determinant. So our determinant is negative 2 minus 0. And then we switch the location of A and B. And then change the sign here. All right. So what we can do then is multiply both sides of this equation by A inverse. So what will happen, we don't need to do the calculations here because, sorry, circled the wrong thing, because A times A inverse gives us our identity matrix. It's going to be 1, 0, 0, 1 no matter what, as long as that matrix has a determinant. And then the identity matrix times whatever our matrix X is going to just be our matrix X. So what we have to worry about for our calculations is doing A inverse times B. So A inverse is here. B then is here. So our matrix X, because when it's multiplied by the identity matrix, is going to stay just X. And then multiply the matrices here first, and then multiply by that negative 1/2, just so that you're working with less fractions. So we are multiplying a 2 by 2 by a 2 by 1, so our result is going to be a 2 by 1 matrix. So we do row times column, so 2 times 4 is 8, plus 0 times 24. And then row by column, we've got 9 times 4 is 36, plus negative 24. So we get 12. Then we multiply that 1/2. So we have negative 4, and then negative 6. And that is our matrix X. And that is how it's going to work for solving any of these equations. We need to find the inverse of the one matrix, multiply that to both sides. That will cause the matrix that's being multiplied by our variable to go to the identity matrix. And then we just have to multiply these matrices, the inverse and the one that's on the other side, in order to figure out what our solution is. Thank you for watching.